How are you, my friends? This is review questions number 1 on vectors in 2 dimensions and systems of equations, linear and non-linear. Question number 1, find the value of k if the 3 lines L1, L2, and L3, these are 3 straight lines, they all intersect in the same point. So we can see clearly here, line L2 has x, y, and k. So we can take line number 1, line number 3, and solve the linear system to find x and y. So I can start with the linear system. I call this equation 1 and equation 2. All right, so I multiply by the LCD in the first one, 2, both sides, and then I multiply in the second equation by 3. So I would get in the first equation 3 times x minus 1 minus 2y plus 1. 6 times 2 is 12 here. Now down I multiply by 3, so it will be 2x plus 3 plus 3y minus 3 is equal to minus 9. Simplify this equation, 3x multiply, and then you will get 3x minus 2y is equal to 17. This is equation number 3, we can call it. And the second one will be 2x plus 3y is equal to minus 6. I'll call it equation number 4. Now, we can use here elimination. So I can multiply equation 3 here by 3, and then equation 4 by 2. So I can cancel the y's because we have minus 2 plus 3. We have to make it the same number in opposite signs, minus 6 as an example, y plus 6y. So when you multiply that, you will get this. Add the two equations, you will get 13x, and this will be canceled, is equal to 39. Divide by 13, x will be 3. That's so easy. Now, x is 3 from the previous slide, and we have equation 3 and 4, so I can use equation 3 or 4. Choose the one you like. I have chosen equation 4 here. And then I replace x3 there to find y. So easily y will be minus 4. So the point of intersection is 3 minus 4. This is the point we can use for the intersection point of the 3 straight lines. So we can replace the coordinates of the intersection point, 3 and minus 4. This is x and this is y in equation 2, which is L2, line number 2. This is line number 2 given kx plus 7y is equal to 20. Replace x3 and y minus 4. You will get k16. Question number 2 is about vectors. Given the vectors u and v, u is a squared minus 2 and v is 21 comma a. Find the value or values of a if the vector u plus v, so you have to add the vectors here. This u plus v is orthogonal to the vector minus 14j plus I. So we can start by adding the vectors u and v. Let's make it easy and call this vector the addition. Let's call it capital X. So let x be u plus v. Just add the components here. A squared plus 21 minus 2 plus a, which is the same as a minus 2. And let's call also the vector y minus 14j plus I. Remember here, minus 14j plus I, you have to rearrange it. So it will be I minus 14j, which is 1 comma minus 14. It is given that the vectors are orthogonal. That means the dot product is 0. So x dot y is equal to 0. So I put the components here, a squared plus 21 times the 1 plus a minus 2 times the minus 14 is equal to 0. So we have an equation, rearrange it, it will be a squared minus 14a plus 49. This is quadratic. You can factor it easily as a minus 7 all squared. This is perfect squared trinomial. So a will be 7. Question number 3, if a is the angle between the vectors e and f, such that secant of the a is minus square root of 6. Let's find the numerical value, the exact number of the dot product of the two given vectors. So we have to find e dot f. Let's start. Look at the given here. The vector E, 2ki plus 10j, I can write it as 2k10. This is AB. And the vector F is I, which is a unit vector. This is 1, 0. So this is C and D. So I can find the dot product of EF. It will be E dot F AC plus BD. So it will be 2k times 1 plus 10 times 0. When we simplify it, simple answer will be 2k. So we have to find the value of the k, then we multiply that by 2. Let's use the dot product theorem here. U dot V is equal to the magnitude of the U times the magnitude of the V times cosine theta. Theta is the angle between the vectors, and it is given capital A. So I can write U dot V, I found already 2k from the previous slide. The magnitude of the U will be square root of 2k all squared plus 10 squared times the magnitude of the V is 1, which is square root of 1 squared plus 0 squared. Cosine of the A is the angle. Secant of the A is given minus square root of 6, so I can find cosine of the A reciprocal 1 over minus square root of 6 or minus 1 over square root of 6, so I can write it here. Now rearrange all this equation, you will get, if you multiply here with the minus square root of 6 on both sides, you get minus 2k square root of 6 is equal to this square root of 4k squared plus 100. Square both sides, you will get 24 k squared is equal to 4k squared plus 100. K squared will be 5. So we have k2 values plus or minus square root of 5. Square root of 5 is rejected. Why is that? Because when you check here, you get square root of 5 for the k. This is a positive number on the left, and it is a negative number because we have this minus here. But when you replace k minus square root of 5, under the radical, it's always positive. You can see that squared here. When you put minus square root of 5 on the left side here in this equation before squaring, you get a negative number. And here also we get a negative number. But inside here, it's always positive because of this squared. So k equals minus square root of 5 is the accepted value for k. What do we need? The dot product we have found. E dot F is equal to k. Remember that. You see here in the top, E dot F is 2k. So the answer will be minus 2 square root of 5. This is the dot product of the two vectors. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.